In the topic A, you know that random variable, distribution function, probability density function, probability mass function. You studied in your earlier class the distribution function and their properties. So, in this session, we are going to discuss about what do you mean by distribution function and what are the properties we are going to discuss. The function f of x is defined as the cumulative distribution function f of x equal to p of x less than or equal to x is called the distribution function of the random variable. Then, first theorem, if the single valued function f of x is a distribution equal only if it is non-decreasing continuous at least one level. Non-decreasing continuous from left there, then it should satisfy the two conditions f of minus infinity 0, f of plus infinity equal to 1. First we have to prove that if x1 is less than x2, then f of x1 is greater than or equal to f of x1, because x2 is greater than the x1. Then the cumulative distribution also for f of x1 equal to f of x less than x1. The probability that x lies in minus infinity comma x1, f of x2 equal to probability of x less than x2. The probability that x lies in minus infinity comma plus infinity, f of x2 equal to probability of x less than x2. Therefore, the probability limit x always lies within the limit of minus infinity comma x2. In general, we can write it as minus infinity, that's upper limit, contains the lower limit, so that the probability lies is greater than the probability that within less than x1. Therefore, this is proved f of x2 is greater than f of x1. The cumulative distribution also non-decreasing from the left. Then second property, the distribution function is continuous on the left there, for which this is always right continuous. Therefore, we are taking the points. These are random variables, discrete random variables. The discrete random variables are always non-decreasing. This is converges to x. To prove that the y n substitute tends to infinity, f of x1 equal to f of x. Let x can be an arbitrary number belonging to the sequence. Consider f of sequence of random variables f of sk comma x, the interval closed on the left and open on the right. Let us denote the random event that the random variable x takes values xk comma x by ak. So, for these random variables, the corresponding event, sequence of events we are defining. You studied in our earlier class. This for that, this is the k1 is less than k2. That corresponding event also we are considering xk comma x greater than or equal to the probability that x takes a value in xk2 comma x. Therefore, ak1 is contains a equal to this event is contains a2. Therefore, ak is a decreasing sequence of event. The limit of a sequence, the point x does not belong to any of the being considered. Let's say intermediate interval is considered. Only the sequence of discrete event only we are considering. The product, because it's a decreasing, non-decreasing, so we are using the pi. Let ak equal to n equal to 1 comma 2 be a non-increasing sequence of event. Therefore, p of a equal to limit n tends to infinity p of a. Therefore, we obtain k tends to infinity p of ak equal to limit k tends to infinity p of xk is less than or equal to x lies between xk to x. Therefore, p of a is f of x minus f of xk. P of a equal to f of x minus limit k tends to infinity f of sk. Therefore, limit k tends to infinity f of sk equal to f of x. Therefore, the sequence is an arbitrary increasing sequence converges from the left to x. Therefore, the distribution function is continuous from the left. So, these are all the properties of the distribution function. We discussed in the earlier UG class and we are continuing here PG class also. If you have any doubt, you can ask me. Thank you.